Hi, my name is Rowan Patical, and in this video we will build on the previous demonstration to integrate a second database table into our solution. By making a few minor amendments to the Join Entries plugin configuration, we will be able to present a single consolidated view of the identity of any employee within the MyComp organization, despite the fact that the data that will be presented is actually stored across multiple directories and tables within a relational database. In this demonstration configuration, in the external MySQL server group under the output node, you can see that we have added a map for a second table on the MySQL database. This map attaches the records stored in the employee data table as entries within the virtual tree under the DN OU equals employee data, OU equals external DB, DC equals my company, DC equals com. Once again, we have used the table key EID as the naming attribute. If we expand the processing part of the configuration and look at the Join Entries plugin under the Join Employee Info processing stage, we can see that an additional foreign data group called Employee Info has been added to the plugin. If we click on this item, we can see that it has been configured to extract data from the virtual branch that we have just attached the new database table to. Once again, you can see that we are going to use the EID attribute to match against the MyComp employee ID attribute in the OU employees node of the accounting directory. With this minor modification, we can start up the instance and see how this additional data has been collated. Let's open the MyComp intranet application, this time and log in as A. Bacon from the MyComp accounting department. As you can see, the user record now includes information about leave days as well as the banking data, which is being added to the user record dynamically from the backend relational database. The user A. Bacon can now look at any user record and obtain the relevant information for that user. Let's log out and log in as a general employee like R. Bird. R. Bird is in the sales department and should only be able to view a limited amount of information about other employees, and certainly should not have access to banking details. But hold on a moment, it looks like R. Bird has the same access rights as any other user and is able to view sensitive information within the intranet application. This is not a situation that we want. Of course, there are two ways that we could handle this. The first approach would be to code the intranet application to recognize different user types and then to control access from here. This is not ideal as it requires code modification and could become a problem in the future if we wish to add further groups or rename different groups. A much better approach would be to implement an ACL within the data layer that limits which data is returned depending on the user that is requesting it. But our solution now consists of data being returned from multiple data sources, including a relational database. Implementing and maintaining ACLs on each resource would be exceedingly difficult and time-consuming, if not close to impossible in some scenarios. So how can we protect sensitive data? Actually, both LDAP Proxy and Virtual Directory Server come with an ACL plugin that offers fine-grained access control over any data returned through the configured instance. By using this plugin, we can centralize our security controls and be sure that we do not impact on the functioning of each of the independent data repositories that are within the environment. We are also able to apply a single policy that applies to data stored in each repository, regardless of whether it is a relational database, Active Directory instance, or an OpenDS server. Let's have a look at an improved version of our configuration. In this demonstration instance, we have added a new processing stage called ACL. In this stage, we attached the access control plugin and configured it to act on the OU equals employees branch within our virtual tree, as this is where most of the sensitive accounting data is stored for each user. Let's assume that the requirements for the intranet application are to firstly allow managers to access all information about any users. Accounting staff should be able to access the banking details for any user, but should not have access to leave information. Finally, all other staff should not be able to access any banking or leave data for any user entry. In this scenario, we only need to define two rules. Firstly, we need to apply a low-level restriction for accounting users, and secondly, we need to define a full restriction for general staff. Managers will have completely unrestricted access. In this case, things are relatively simple as our users are logically grouped into separate directories. In the first rule, we simply add the rule to anyone who authenticates and is stored in the DN OU equals users, O equals accounting, DC equals mycompany.org. We allow the user to browse entries, but we restrict access to particular attributes such as the leave days that we want to protect. This rule will serve to allow accounting users to browse user records while protecting the leave data for each user. The second rule is more pervasive. It applies to anybody who is authenticated from the DN OU equals people, DC equals my organization, DC equals com. These users are also able to browse entries, but the list of attributes that we have protected is much larger and includes banking and tax information as well as the leave data that we are extracting from the database. Of course, this processing stage has been attached to the listener in front of the virtual tree to ensure that the rules are implemented before any data is returned by the virtual tree. Let's see the configuration in action. So we click on the Run button to start the instance, and now, if we return to the MyComp intranet application, we can attempt firstly to log in as a manager. Let's log in as myself, Rowan Puttigal. As expected, you can see that I still have full access to all of the data about any user record. Here I am able to see leave data as well as bank account details. If I log out and log in as a user from our accounting department, such as A. Bacon, you can see that while I am able to view the banking details for any user, I am unable to see any leave information. Finally, if I log out and log back in as our sales rep, R. Bird, you can see that R. Bird does not have access to any of the sensitive data that we have chosen to protect using our ACL plugin. In a few minutes, using Virtual Directory Server, we've been able to present a completely consolidated view of user entries across numerous data repositories. We have also been able to protect this data and define very specific rules about who should be able to view particular attributes. To some degree, this was made much easier by the fact that our users were already logically grouped into different branches, and our rules were specific to which branch a user might be authenticated from. In many environments, you may define particular groups to which your users can belong. The ACL plugin is equally able to work with groups, whether they are static or dynamic. Unfortunately, we have run out of time to demonstrate this functionality in the current video, but we hope that you have got a clear picture of how quickly you can resolve identity infrastructure problems using LDAP proxy and Virtual Directory Server.